is represented by the shaded region of the Venn diagram below. So we are given 3 sets problem where this is T, this is R, and this is C. T and R have common elements between them. Don't forget that this is intersection. All this, where they overlap each other is called intersection. Okay? So from this question now, we can look at the option and compare that this is intersection. It's supposed to be T intersection R intersection C, or C intersection T intersection R, anyone you like. But according to the option now, you can see that only T and R have something in common, but C is left out. C does not have anything in common at all. So that implies that T will take complements. It will take complements, and this one will be coming together like this. Only C will take complement because it's not participating, it's not having anything in common with that set. Take note of that. So now, number 7. So this option of number 6 can be found in, that is option C. That is option C. Number 7, we have root 72 plus root 32 minus root b equals to 6 root 2. The question asks us to find the value of b. This is sod. Okay? And in sod, when you look at question in sod, when they give you a sod like 72, what you do first is to see how you can break it into 2 factors. Take note of that. How you can break into 2 factors, A and B, such that if one of them, either A or B, must be a perfect square, and the other may not be a perfect square. So whenever you want to break a number in short form, the 2 factors you are going to use, try as much as possible that you bring out a perfect square from there, if there is at all. But if there is no perfect square, then there is no problem. But the first thing to watch out for is a perfect square. What do I mean by a perfect square? Numbers whose square roots is a whole number, like 4, like 16, like 25, like say 100, and so on and so forth. These are what we call perfect. Even 1 is a perfect square on its own, but these are the things you watch out for. Even 36 is a perfect square. 49 is a perfect square. So and so on and so forth like that. So what I will do here now, root 72. Root 72 now, look at the factor. Of course, 9 times 8 can give me 72, but I can still bring out something else again from this 8. 8 can also be broken to 4 times 2. Now, if I look at it, don't forget there are 2 factors. One of them must be a perfect square. So why not bring this 9 and 4 together and make it 36 times 2? Okay? So now this is 36 multiplied by 2. This is preferable. The highest number so far of the perfect square is what you use. So plus, now this is 32 again. 32 can be 8 times 4, but the method I gave you now, that the highest perfect square you can get from that number, so that is 16 times 2 as well. Then minus root b equals to 6 root 2. So this is preferable. What is the square root of 36? The square root of 36, the reason for that is because you can easily get the square root. So the square root of 36 is 6, but the square root of 2 is a decimal number. So you will keep it like that. If it's a decimal number, you keep it as root 2. Plus, look at this 16, and the square root of 16 is 4. And the square root of 2 is a decimal number, so you keep it as root 2. Then minus root b equals to 6 root 2. Since these ones are like terms, root 2 here, is like saying 6x plus 4x. They can be added. 6x plus 4x is 10x. So the same thing will happen. Whole number and whole number will be added. Root 2 plus root 2 we just pick one. That is 6 of root 2 plus 4 of root 2 is equal to 10 root 2. Okay? Now, minus root b equals to 6 root 2. Can you take minus root b to that side and bring 6 root 2 in to the left side? So this is 10 root 2 minus 6 root 2 equals to root b. Of course, this one will turn to positive here. This is another like term. 10 root 2 minus 6 root 2. So this one will also give us 4. Give us 4 root 2, which is equal to root b. b. You can square both sides to remove the square root. This is so this square will take care of this b. This is 4 square times root 2 square, which is equal to our b. What is 4 square? 16 times root 2 square. This root 2 will take care of this one, so we have 2 here, and that is b. So therefore our b is equal to what? 2. And that can be found in the option C. Now, number 8. Okay, we don't have number 8. That is all for objectives. We now move to the theory aspect of the question. Now, if you look at this question 1, the essay part, this is modulo. At times you call it module or modulus. Okay? Now, the meaning of mode means dividing a number by another number. And whatever you get is the remainder. Whatever you are seeing here, you have a set 2468 and another set 2468. And whatever the modulo operation generates, they are the remainders that you can ever find here. Okay? Now, we are told that the operation is working on multiplication, but we are not given the exact mode that we are operating with. Okay? Now, the question is even asking us to find the mode of operation. That is mode P. That is, we have to find that modulo P. So, if you look at the multiplication table very well, it's that this is 2 times 2, 4. 2 times 2, 4. Since it means that for us to have 2 times 2 to be 4, and we are writing that 4, it shows that this number that is here is more than 4. Take note of that. You can even see another one. 2 times 4 here is 8. That shows that the number, the modulo we are operating on is not up to, this 8 is not up to this modulo. That is why we are writing it like that. And if that is up to, then we will have written the remainder. What you see here in the table, what the set will generate must be the remainder. Take note of that. Now, look at this one. 2 times 6, which is supposed to be 12, but you can see that they are writing 2. That shows that the modulo we are using is somewhere is more than 8, just like I have said. But how do you know it? Normally, the operation should be 2 times 6 now. We are supposed to have 12, but we are having 2. That means that you subtract 2. If you subtract 2 from 12, that will give you 10. It indicates that it's like they are working on 10, on modulo 10. Let's look at it. Now, we said 2 times 6 is 12. Now, let us see. 12, that 12, divided by this modulo 10. Okay? What are you going to have? 10 in 12 will give us 1. And remainder what? Remainder 2. Can you see?
Yes.
That remainder 2 is what they have put here. Let's look at a complete set. Let's look at a complete set. Okay, look at this one now. 6. Okay, this is just like what you have done. Look at this one. 6 times 4. Look at the under that. 6 multiplied by 4, we are having 4. How? That means 6 times 4 is 24. Let's look at it. 6 times 4 is 24. But we are not having 24 here. We are giving us a remainder. So let us see whether that 10 will work. 24 divided by 10. That is 10 in 24. That will give us 2 because it's 20. Remainder 4. So which shows that the operation, the mode of operation is modulo 10. So when you are not given the modulo or what you are supposed to use to divide, but you are given the remainder, okay, what you just need to do is to subtract this remainder. Just subtract it from the main number that is supposed to be. That is the modulo. Do you understand now? So the modulo of operation here will now be 2, okay, 2 times 6, which you said is 12. 12 minus, that is the remainder now, which is 10. So therefore, P, which is the modulo, is modulo 10. That is what we are doing. So to answer question B, we are asked to find one of the unknown there. That is Y. Okay, let us see what will happen here. 2 times 8 is 16. So what is going to remain here after you have divided it by the standard modulo? So what we are told that we have already gotten that to be 10. So we can come back to the question and say 2 times 8 is 16, but we modulate with 10. When we modulate with 10, that is 10 is 16, it gives us what? That is 1 remainder 6. So automatically that particular place is 6. So therefore now we can say that our y is equal to 6. So now let's go to question 2. Question 2, we have a diagram here. This is Q, this is P, this is R. We have right angle here. We have S, we have angle 90 somewhere here. We have angle 60 degrees here. We have 8 centimeters here. And this is 45 degrees. If you look at it, before you start, these are special angles 60 degrees and 45 degrees. So after the story, they ask us to find the length PS. We have to find length PS in this question. So how do we solve that? If you look at it, length PS, this is the unknown we are looking for. Now, what about this place we are not given? That is the adjacent, because this is the opposite. SR is opposite, PR is the adjacent, but none of the two sides is given to us. So, but there is one almost complete equation, complete information that we can actually use to get this side. We are given the hypotenuse 8, and we are given the angle, so it's easy for us to consider this angle PQR, so that when we get this place, using our SOHCAHTOA, we can now use this information, this whatever you get, and this 45 to get what we need. It's a very simple question. So what you just need to do is to consider triangle PQR first, and it's in form of this. This is triangle, this is P, this is PR, then we have our Q here, we have our angle 60 here, this is our 8 centimeter. Okay, so this is our right angle. Now, this is the hypotenuse. Don't forget that we need PR. If you can get PR, which is the opposite, this is the opposite. So when we have opposite and hypotenuse, what are we using? That is sine from that word SOHCAHTOA. So we are going to have sine 60 degrees equals to opposite. Opposite is our length PR over our hypotenuse 8. So our length PR equals to 8 times sine 60 degrees. Our length PR can give us 8 times sine 60. As a mathematician, you must know this is a special angle. You must know it often. The trigonometric ratios of special angle. Sine 60 is root 3 over 2. So 2 here 1, 2 in 8 here 4. So we have 4 root 3 centimeter. This is length PR. This is 4 root 3. This is 4 root 3. Now we can now use it, 4 root 3 centimeter, we can now use it to get the other angle. Now consider triangle PSR or PRS, as the case may be. We have gotten this place to be 4 root 3 centimeter. This angle is 45. This is our PSR. This is our angle 90. Now we can use that to get this. When we are looking for the hypotenuse, and we also have this is the adjacent. Take note, this is opposite. We don't have anything here. This is our adjacent. So when you have adjacent and hypotenuse, of course, that is car. So we can say cos 45 degrees equals to adjacent 4 root 3 over hypotenuse. We are looking for that. That is length PS. So you can 45 cos 45 is root 2 over 2. Just like I told you, we must know all these special angles of hand. So you can cross multiply and have root 2 multiplied by length PS equals to 2 times 4 root 3, that is 8 root 3. You can divide both sides by root 2. This one also by root 2. So this is solved. And when you have an irrational number at the denominator, what do? You rationalize. So you can say times, this one will have cancelled each other. You can say this one is times root 2 over root 2. And that will give us 8 root 3. Root 3 times root 2 will give us root 6 over root 2 times root 2. You just pick 1, that's 2. 3 here 1, 2 in 8, 4. That will now give us our length. Therefore, our length PS will give us 4 root 6 centimeters. If you multiply, use your calculator, you can have 9 point something, that is 9.8 centimeters.